Okay, hello everyone. So today in this video, we're going to look at 11.5, where we will learn one new concept called the R formula. So actually what is R formula is actually one of the more useful tools that we see in trigonometry, right? And the purpose of using R formula is to combine a sum of sine and cosine function into one single sine or cos function. Okay, so when you have like a sum of sine and cosine or a difference of sine and cosine, we can transform them and collapse them into one single sine and cosine function, which should make calculations easier, which should make some analysis easier. Okay, so another context that we can give is actually through this function over here, right? So when I have 2 sine theta plus 45 in brackets, right? When I expand them, I can actually use the addition formula to expand them. Alright? And after using addition formula to expand them, so this is what I get, and this is my final answer. Okay? So now we are wondering, right? So when we use addition formula, it is to expand and obtain a sum. Okay? Now we are going to do the reverse. We are going to go from the sum back to a compressed version using the R formula. Okay, so without further ado, let me quickly show you what is the formula for your R formula first. So the formula is like this. When you have A sine theta plus B cos theta, when there's a sum of one sine and one cosine, you can add them together and combine them into R sine theta plus alpha. So A and B are the coefficients of the sine and cosine respectively. R will be our new coefficient, and this alpha is the acute angle that will need to be affected. So this alpha would be something like this 45 degree over here. Okay, now this is the sine version. I'm going to tell you what is the cosine version as well. So the cosine version is like this. I have A cos theta plus B sin theta is equals to R cos theta minus alpha. So take note of this sign, plus and minus, and if it's minus in front, then we do a plus. Okay, so the thing is very important is that what is the leading term? So if sine is leading in front, we can compress them. It's better to compress them to a sine. If cosine is leading in front, it's better to compress them into one cosine. Okay, so why does this matter is actually because of the use of when we calculate the R and the alpha, where R is equals to A squared plus B squared and square root, and the alpha is equals to tangent inverse of B over A. Alright, so this B over A is the one that will give us the alpha. Okay, and the sequence is very important. Which one is the B? Which one is the A? So if sine is in front and the question asks you to convert to sine, then it's fine. But if sine is in front but question asks you to convert to cosine, then you should do a swap so that you can have a good sequence of A and B when you do your calculations. Okay, so this is the formula. And one more thing to take note is over here where A and B are positive numbers. It's just that the sign will be plus minus minus plus, right? So those signs will be like these signs over here would be independent. It's just that the A and B usually we have positive values. Okay, it's just that plus a positive value or minus a positive value, and this alpha over here will be always acute. Okay, we won't have any obtuse angles. Okay, so now before we continue, right, let me quickly show you a proof. So if you want, you may skip this. Okay, but I will show you a proof on why this works. Okay, so the thing is, I'm going to I'm going to only prove for the first case. Okay, I cannot prove for all the cases, but okay, because it's too tedious and there's not enough time. But so I'm just going to prove the first case. The rest you can pretty much do on your own. Okay, so I'm going to let A sine theta plus B cos theta to be equals to R sine theta plus alpha. I want to let it to be a compressed version. And what I can do is I can then expand the compressed version using the addition formula. So I will have an R, then I will have a sine A cos B plus cos A sine B using the addition formula like that. Okay, so let me expand this. So A sine theta on the left, B cos theta on the right. So this would be R sine theta cos alpha plus R cos theta sine alpha. Okay, cos A sine B sine A cos B. Then we can do a little bit of comparing coefficients. Okay, so with this, right, let me rewrite this as R cos alpha multiplied by sine theta, and I have R sine alpha multiplied with cos theta. I'm just swapping the position. Okay, so over here, if you were to compare the sine theta on the left and on the right, now my A is going to be R cos theta. Okay, now then for this one, let's say if I have an R sine theta, if I were to compare the cos theta term, so my R sine theta is going to be equals to B, like that. Okay, so comparing coefficients. Okay, comparing coefficients, right? So I have an A is equals to R cos theta, or more like I should put it the other way around. R cos alpha is equals to A. So this would be 1, equation 1. And I have R sine alpha is equals to B when I compare coefficients. Okay, so now with this one, I can actually do two operations to it. The first operation is I'm going to take 1 square plus 2 square, and I'm going to see what happens. So when I have 1 square plus 2 square, I'm going to have 1 square is R cos alpha square on the left plus R square sine square alpha on the left as well. Then this will be equals to A square plus B square, right? So when I factorize this, I'm going to have a cos square alpha plus sine square alpha equals to A square plus B square. Okay, now however, we know from the basic identity that this is going to be equals to 1. Okay, let me do this with a lighter color. Oh dear. Okay, let me do this with a lighter color. So this one will be equals to 1. So hence R square is equals to A square plus B square, and the R will be A square plus B square and square rooted. Okay, so this is where we get the R from. Okay, how we obtain the R. Now, the second thing is that we can make use of tangent. So I'm going to take I'm going to take 2 divided by 1. So I have an R sine theta, R sine alpha over R cos alpha is equals to B over A, 2 divided by 1. Okay, if you can see this. Now, then I can do some cancellation. R can cancel. Then I will have a tangent alpha is equals to B over A. So if I were to look for alpha, it will be tangent inverse of B over A, like that. Okay, so what I'm proving is I will need to prove the result for R and the alpha. Okay, so once again, don't worry if you don't understand the proof. It's just to show you where does it come from. The more important thing is to know how it works, right? So we're going to make use of this, and we're going to show you how it works below. Okay, so let me copy this, and let us jump straight to try 18 over here. And I will park this over here for reference. Okay, so for try 18, let me go to part A. Now, I have 2 sine theta plus root 3 cos theta. So if the question never specify anything, we are actually free to choose what to combine to. We can combine to one single sine, or we can combine to one single cosine. It's entirely up to us. However, most of the time they would determine what should we convert to. Right, usually the conversion will be stated in the question so that we won't be confused and it will be exactly what the question wants. Okay, so let's further assume that for this case, right, because sine is in front, so I will need to convert to a sine. Okay, so let me put this as R sine, right, theta plus alpha. Let me do in this format first. Okay, so for sine, if in front is a plus, this will be a plus. I don't need to flip the sign. Okay, now let me calculate my r. My r would be 2 square plus root 3 square root and squared. And then the whole thing would be square rooted. So I will have a 4 plus 3. So this will be root 7. Okay, then my alpha will be equals to tangent inverse of b over a. So this would be giving me tangent inverse of this over a. So this will give me around 40.893 degrees. So I will give a little bit more what to call accuracy. Okay, so with this one in mind, with this conversion in mind, so my 2 sine theta plus root 3 cos theta is equals to root 7 sine theta plus the alpha 40.893 degrees. Okay, so if they normally one angle in one decimal place, so we will just convert it to 40.9 degrees. Okay, so this is how we do it. Okay, very easy. So we don't have to go through the whole proofing step. We will just need to calculate the r, the alpha, and we just sub in the r and the alpha. Okay. Now for b, because cosine is leading in front, so I'm just going to assume that I'm going to convert to cosine. Alright, otherwise it will be stated in the question. Okay, so let me let this be equals to r cos. Now let's take a look at the format. If this is a minus, right, this will be a plus. For cosine, we normally flip the sign. Okay, so if this is a minus, the cosine r formula will be a plus. We normally flip the sign for cosine. For sine, we will need to follow. For cosine, we will flip. Okay, so let's calculate our r. Our r would be a square plus b square. Right, a square plus b square. So this one will be equals to 5. And our alpha would be equals to tangent inverse of b, the positive value of b, over a. So tangent inverse of 4 over 3 gives me 53.130 degrees. Okay, so therefore we have successfully converted this sum of 3 cos theta minus 4 sin theta into 5 cos theta is the unknown, right? Theta is the unknown, plus an adjustment alpha, so 53.130, like that. So 5 cos theta plus 53.1 to 1 dp. Okay, so this is try 18, question 8, question B. Now if we were to look at the example 18, there was this one question with a negative in front and the back for this one over here. Alright, this one over here, right? We have this one, example 18b, where you have a negative 2 in front and a negative 3 over here. So, but we cannot apply the R formula if both these numbers are negative. Normally, it will be one positive, or both positive, or one positive or negative. So, for this case, what we need to do is a bit special. We will need to factorize the negative out before proceeding to do the R formula inside the bracket. Okay, so this is the advice that we need to give you, is that normally the leading term must be positive. Okay, so this is for example 18. Now let us go straight to example 19. Now one purpose of doing this R formula is to find the maximum and minimum value of a combination of sine and cosine function. Okay, so the thing is, and we on top of looking for maximum and minimum, we need to find the corresponding values of theta. Okay, so we need to find the corresponding angle such that we have a maximum or the minimum, and this is actually quite straightforward. Now for this one, for this case, I'm going to let, right, I'm going to let now 6 cos theta minus 4 sin theta minus 2. Okay, now I'm going to let this one, okay, sorry, I'm going to let this, so actually don't need the negative 2. So I'm going to let this be equals to, okay, because the cosine is in front, I'll let it be equals to r cos theta. Now, if the sign over here is a minus, I can put a plus over here, theta plus alpha. Okay, so what I need to do is to get the r and the alpha, value of r and alpha. So value of r is 6 square plus 4 square. Okay, so 6 square plus 4 square will give me root 52, right? Then alpha, so alpha is equals to tangent inverse of b over a. So the b over a, so my calculator will give me 33.6900, okay, or 690, okay, like that. Okay, so then because of that, 6 cos theta minus 4 sine theta is going to be equals to, oh wait, and then I need a minus 2, right? So minus 2 is going to be equals to the r, which is root 52, cos theta plus the angle that I found, 33.690. So take note, yeah, when you have a cosine, you need to flip this sign. Okay, so inside the bracket will need to be flipped. Okay, now and then I need a minus 2 on the outside. First, that one is left outside. What I did is to do R formula for this only. The 2 is still outside. Okay, now so the next important thing is, now when is it maximum and when is it minimum? It's actually based on, you remember, if a cos bx plus c. Do you remember this thing? So where is the maximum? The maximum will be a plus this. Sorry, it will be the midline c plus the amplitude, the maximum. Okay, the minimum will be this one minus the amplitude. Okay, you see this? So this is what we did in the graph earlier, the trig graph earlier. Okay, so let us do this. So the maximum is equals to the maximum value, right, is equals to the midline negative 2 plus root 52. Okay, whereas at the same time, the minimum value, okay, is equals to negative 2 minus root 52. Now, how do I know this is true or false? Now, the longer way to do this is, now, cosine of anything, so this is the alternative way, the longer way to do this. So cosine of anything, right, is going to be minimum -1 and maximum 1. Okay, now when I multiply everything by root 52, okay, when I multiply everything by root 52, so the one on the right is root 52, the one on the left will be negative root 52, and last but not least, this one over here, right, this one over here, right, I need to minus 2, correct? So what happened is, this one I will need to minus 2 over here, plus root 52, I need to minus 2 on the left. Okay, so you see, this is the minimum, and this one over here is the maximum. So there's two ways to do it, the long way and the shorter way, right? So the shorter way is to make use of the fact that you can use the midline plus the amplitude and minus the amplitude. Okay, now then the next question is, now after looking for the maximum and minimum value, I'm looking for when is it maximum and when is it minimum. Okay, so when is it maximum? Now this one I will need to refer to my cosine graph, right? So based on the cosine graph, like this, right, cosine graph, right, when is it a maximum? It is when the angle is 0 degrees. Okay, so this means that I'm looking for the 0 degrees. So this is when, right, the angle inside, so the angle inside the cosine function, so this theta plus 33.690 is going to be equals to 0 degrees, but it will be negative 33 degrees, right? So I cannot take this angle, so instead I will need to take the 360 degrees. So my theta is going to be 360 minus this answer, so this will be 326.3099, which is equals to 326.3 degrees. Okay, so when the theta is 326.3 degrees, the maximum value will be this. Okay, then what about the minimum value? It happens when, okay, over here, right, over here. It happens when this angle inside the cosine function, right, the angle inside the cosine function, it is equals to 180 at the minimum value. So theta will be equals to 180 minus 33.690. So I will have a 146.31 degrees. Okay, sorry, let me write this completely. 3099 again. So this would be 146.3 degrees like this. Okay. Now the longer way to do this is now when the whole thing, so root 52 cosine of this whole thing minus 2 is equals to negative 2 plus root 52, right? So then I will have a root 52 cos of this ugly angle is equals to root 52. Then I can divide cos this is equals to 1, and when cos this is equals to 1, this angle is over here, right? This angle over here would be 0 degrees or 360 degrees. Then I will need to minus the content inside to get my theta. Okay, but however, what we did earlier is to jump to this step right away. Right? Knowing for a fact that the cosine graph is using that behavior, you can jump to this directly. Okay. Now, so if there's any problem, feel free to ask me questions over the day. Okay, and yeah, if there's any problem, right, be patient with yourself because you need time to get used to this. And I think that once you do a little bit more practice, you should be okay. Alright, now let's look at the last thing that we want to go through today, which is actually we can use this to solve this kind of equation. Right? So previously, right, when we have a cosine and sine equals to 0, we can just shift this to the other side and divide sine and cos to make it a tangent. Very nice. Okay. However, for this one, we cannot make a tangent. Very sad. And we cannot square because there's no identity for us to square. Like it's not a cos square sine square thingy, right? So we can't do the identity, right? So the only thing that we can do to solve is to make use of the R formula. So what I can do is to transform this to an R formula, a single one, then I can remove this slowly. So let me let this cosine theta minus root 3 sine theta equals to, okay, I will make use of the R formula first. So it will be R, the cos in front, so I'm going to use the cos version, and I have a theta and alpha, right? So if you notice, this is a minus. What I need here is a plus. Okay, like this. Okay, so this is how I form the thing first. So my R would be equals to, now there's an invisible 1 here, so this would be a 1 square plus a root 3 square. Okay, so when I do all these things, it will be a square root of 4. Then this will be equals to 2. Then my alpha is equals to tangent inverse of, now, B over A. So this is going to give me a very nice thing of a 60 degrees. Okay? So therefore, my cos theta minus root 3 sine theta, right, equals to 2, right? So this thing is equals to 2. Right, because and then I can replace this with a R cos theta plus alpha, like this. It's going to be equals to 2. Okay, so then we solve the equation like this. Alright, so because previously we can't solve it directly, but now we can remove the 2, remove the cos, remove the 60 to get the theta, like that. Okay, so let's remove the 2 first. So I will have a cos this angle plus 60 is equals to 1. Okay, can so what about when cosine is 1, right? So 1 is actually a very special angle where we need to start to consider the graph. Okay, like this, we need to consider the graph. So when this is 1, so I need to think of the 0 degrees, And I also need to think of the 360 degrees, just in case. Okay, so over here I will have a, okay, so theta plus 60 degrees is going to be equals to 0 degrees, or theta plus 60 degrees is going to be equals to 360 degrees based on this trigo graph over here. Okay, hopefully let me shift this up. Okay, easier this way. Okay, it's at 0 degrees and 360 degrees over here. Alright, can so with this one over here, theta is equals to negative 60 degrees, and we check whether does it fall inside this range. It does not fall, it falls outside. So this one we actually reject. Okay, we put NA, or we actually can put a reject because the theta must be positive. So this one, theta is equals to 300 degrees. So this is the only place where it will be accepted, okay, for this question. Okay, so for our formula, I think we are done for the day, right? So without further ado, what I would like you to do is to head over to this one and to try a few questions over here. What I would like you to try is to try question 2 in the exercise 11.5, and also to try one more solving equation, which is actually number 7. Okay, so number 2 to find the maximum minimum, and to look for number 7. Okay, now for the other questions involving like the modeling and so on, we'll deal with it another day. Okay, so that's all for today's thing. We'll just go through the question 2 and 7 tomorrow, and I will go through the problem solving questions tomorrow, as the next day as well. Okay, so hope you have a nice day of studying, and I hope this won't be too overwhelming. The R formula is something that you must master because it's a recurring question every year. Okay, so hope this makes sense, and hope this video will give you a good shortcut on how to find the R formula for the trigo sums. Okay, so that's all for the day. Thank you so much and have a nice day. Bye bye.